Alright, another day, another episode of Made Up of Wires. We are decompiling Castlevania Symphony of the Night. I'm going to do my best to keep track of chat, keep track of everything that's going on. Let me give you a little overview of the project, and then we'll do something a little bit different at the start, something that kind of came up towards the end of last week, and then we'll look at some more weapon functions, I think, again. The one I started on Thursday was reasonably difficult. It's getting close, but not quite there yet. So if you're not familiar with the Castlevania Symphony of the Night decompilation project, we are trying to decompile Castlevania Symphony of the Night for all the platforms it was released. Primarily, the work so far has been done on the PlayStation version of the platform, but we're also looking very closely at PSP, which uses a different compiler and helps us out a lot trying to solve some of the decompilation issues with the PlayStation. Hey Roaming, nice to have you in chat. But there has been some work done on Saturn versions of the game, and we've looked at the Xbox 360 of the game as well. There's some documentation there, as well as more modern ports, the mobile ports that were done slightly before the Requiem collection. I don't know if much work has been done looking at the Requiem collection itself, but it looks like those are relatively similar to what was done on mobile. And so what we would like to do is have C source code that we can recompile and produce matching binaries for all the platforms that the game was released for, but then also have kind of a base for modders and other people who want to go and maybe port the game to other platforms, or maybe create an entire game based on what's available in that source code. Make that open to anybody who wants to look at the game. So if you go to soten.z.dev, you'll find status for where we are. I did actually spend a little time looking at the last function in the Dracula bin game engine. This function is translating characters, I believe, from Japanese to a font palette that's embedded in the game, and there's some odd math that has been giving people problems. So that one is still unsolved, and it'll go for a while. The Richter program, that one has been completed for a while now. We have 3 weapons left in Weapon 0, or 3 functions left in Weapon 0, I should say. And then several stages. And I believe we will have a boss coming in soon. There's work being done as well. Actually, looking at the build, that file is already building. So we have a... no, maybe it's not a boss. Maybe it's the Marble Gallery. The Marble Gallery stage, and there's a boss in that stage where some work is being done. You can go to a link at the top of soten.z.dev, which will take you to the GitHub repo, where all the things that have been decompiled and are matching are checked in. And then there's also a link to the Discord server, and there's been a lot of new people in the last week that I think have found this stream or seen the videos on YouTube and have been dropping by and contributing in the Discord channel, and lots of thanks. So far, everything I've seen has been extremely positive. When you see a new influx of people in any project, there can be some churn, getting people set up and making sure that people have the right tools. And I happened to go away for the weekend, and a bunch of new people came in, and I was a little upset for myself, with myself, for not being there to kind of help with that onboarding. But Biz Murphy and Sozu and a bunch of other people, Zeranimo himself, they jumped in and helped, and it looks like we have a bunch of new contributors, which is awesome, and I'm glad that people are finding the project and are able to help. Related to that, today I think I'm going to spend the first part of the stream going over project setup. There's been some issues that I've had. I've set up the project maybe 3 or 4 times First, I had it set up in a VM, and then I bought a used Dell that I could kind of dedicate to this project, so I can get faster compiles and other things like that. And then something happened with that. I reinstalled everything, and I think I had to set it up again. And I've gone through enough of the process trying to set up a working macOS environment, which is not possible yet, as well as a free BSD environment, and there's some dependencies missing there as well. So I've gone through the setup process several times. And so I'm going to walk through what setting up on an Ubuntu 24 environment might look like. This will be a little different for WSL, Windows Services for Linux, as well as Arch Linux, which a lot of people are using, and whatever distro you use is going to be a little bit different. There's also some idiosyncrasies and differences. Our main build infrastructure is Ubuntu 22, and there's some differences between 22 and 24, specifically around more modern Python that need to be taken care of. And I'm going to try to get some of the changes that I talk about today checked into the repo so that they're not an issue for other people that want to go down this path and are using a more modern Ubuntu. So we'll start with that, and then I think that might take 20-30 minutes or so, and then we can move on to decompiling. So chat, I made, somehow in YouTube I have been hitting more recommendations, or hitting more people's recommendation lists. A lot of people watching the videos there, which is awesome. Lot of support, and I really appreciate all the positive comments. I always want to reiterate, I found this project 4 months ago or so. My first contribution was a relatively minor change to how disks were being extracted, and I'm going to go over some of that today as well, because I like to rip my own copies of disks as opposed to getting them elsewhere, we'll say, through more gray market means. And so the tools that I use for ripping my own disk produce different files than what most people might have on their own systems, procured whatever way they may have downloaded the game. Dumped the game through legal means, of course. So I'm going to go through what my process is for ripping my own disks as part of this setup as well. And that will produce a file that is different from what the randomizer expects, and possibly also what the Soten level editor tool, I haven't looked deeply into that, but I think tools that deal with offsets in a bin queue pair, or it seems like most people are using multiple bins to a single queue. This won't necessarily work with this. It should work with any emulator, though, and it works with all of our tooling as well. So I'm going to get into this. I will have some asides for things that I need to change in the repo to have this working on Ubuntu 24 that I would like to try to get checked in later today, but I didn't have time to check in quite yet. So to do this, I'm gonna use Docker just to give me a clean environment, but this can be done on any Ubuntu machine. This is just going to be a brand new, fresh Ubuntu 24 image. I'm using 24.10. It should be the same instructions for 24.4. So my Docker file is just pulling in that Ubuntu 24.10 base image, and because I want to extract my CD, I'm mapping my CD drive as well, and giving myself read, write, and modification permissions in the image. And I'm just going to go into Bash. So Oh no, oh, drat. Oh, that's why. Alright, so I have this image. This will put me in a root shell, and I'm going to do some things as root before I drop into my user. And that's primarily because it's easier to install packages that way, and I don't have sudo set up on this instance. A comment. Is it okay if you work on scratches? Any scratch, and I mean to do this in future streams as well, any scratch that I'm editing, I'll be logged in. It's with the account linked back to my GitHub account. You won't be able to edit that specific scratch and save anything, but you can fork it and save your own. And then there's a family list that'll show all the forks of a scratch. So yeah, feel free to edit anything you want. This is definitely a team effort, and so if people can make progress beyond what I've done on any of the scratches, that is awesome, and send a PR and get it checked in. Let's see. All right, so let's get started. So I'm logged in just as root on a brand new Ubuntu install. For the sake of this, I need to give my user. I'm going to do most things as my user, but while I'm root, I need to give myself permission to the CD device. So that's just done with chmod. I'm going to give everybody on the system, which is me and root, access to that CD-ROM. And then I'm going to drop into my user and go into my home directory. I like putting my projects in a directory called projects. You can put it wherever you'd like. And then I need to clone the repo. And let me post this wiki. Many of these instructions are exactly the same as what's on the wiki. And when I'm done documenting this, I'm going to update the wiki, because there's some things that are more complicated there than need to be. So I'm going to post a link in chat. If paste would work, which it doesn't seem to. There we go. Yes, this is definitely collaborative work. It is cathartic for me, and I do enjoy it, and I get a lot of pleasure from decompiling. But ultimately, if we can't get a full decompile, we haven't succeeded. And so I want as many people who can contribute as possible to contribute. All right, so back to what I was working on. In chat, there's a link to the wiki that I'm mostly following. I'll point out where I'm diverging. So I'm going to clone the repo, and this is just a standard git clone. If you've not used Git before, you probably should learn a little bit about it before looking to contribute, because that's kind of out of the scope for what we can do. Yes, 8. I'm up to 8. It is wonderful. Yeah, and I'm glad that people are interested, and I'll keep doing it as long as people are watching. So clone the repo. That just means I copy down that repo and all the changes. I'm going to go into the repo directory, and I'm sorry that my terminal isn't colored. That would make it much easier. Maybe I should copy my PS1. Is that better? Oh yeah, look at that. Beautiful. Um, yeah, Twitch becomes just MIPS decompilation projects. That will be the day. That will be the day when 8 people are on Twitch. All right, so we've checked out the project from GitHub, cloned the project. The project relies on several submodules from related decompilation projects and tools. So we're going to use git submodule update, which will go through and fetch each of those tools and put them in the appropriate places in that project path. So now that we have the project downloaded, I'm going to go back to my root shell where I'll do the installation of other packages that are requirements for this. If you were on a normal Ubuntu box that was set up, you'd probably just use sudo to do this, but since this is a minimal install, I have very few things pre-installed. So that is just going to use apt, and all the Debian requirements, Debian Ubuntu related distributions are in requirements-debian. There are requirements files for at least Python, maybe some others as well, we can look. But this will go through and install packages and all their dependencies. It'll take a little bit. When we get to the disk dumping part, that will take a while, and maybe we can do some decompilation while that's running, because it takes, I don't know, 5 to 10 minutes. In this case, it's going to stop because I have a very minimal install. It's going to stop and just ask me what time zone I want to be in. So I'll answer that. Usually that can be unattended. And then for this case, because I want to be focusing on using VM for Python as well as using CDR DAO for dumping the disk, I'm going to install those as well. Currently, this part is not in the wiki. I installed Vim as well because that's the text editor that I use. That part's not in the wiki, and hopefully sometime today or later this week, I'll push some of these changes, and it'll make things a little more convenient, I think, for the Python install. All right, so now I'm going to go back to my user. Again, if you're using sudo, that's not a step that you do. And I'm going to set up VM, which is kind of the current way of managing Python dependencies for the user. So in the past, you might use pip to install dependencies, and they'd go into regular system directories. For Ubuntu, FreeBSD, lots of other package managers, system package managers, they have parallel packages for each of those things. So when pip was installing things, it might be installing things to the same place that apt was installing them to. And so, plus you might have different projects that are using different versions of those dependencies, and VM kind of helps with all of those. On the other hand, the tooling that has been built so far is built around this idea that you're using the system Python. So we're going to diverge a little bit from that, and hopefully this becomes kind of the new state of the art, but we'll see. So when you use VM, basically you need to say to your shell and to everything that's going to call Python, don't use the system Python anymore, use the one specific to my project. So I'm going to source this activate file. Source tells your shell bring in all these things that are related to environment variables and other things like that. And then when I run pip, it's not going to install to the system anymore. It's going to install to this local environment that I've created. So I'm going to run pip install, and we can use the this Python requirements file. and this will install all of the Python dependencies that we need. So there, because this isn't checked in and VM isn't used in the standard build system, we're going to have to edit some files. I'll get back to that in a second. The thing I'm going to do next is rip my personal copy of the disk. So I use CDR DAO. There are other tools that can be used. There is, what is the... Redump.org has a bunch of tools there. Redumper is their tool. I don't see Redumper either in apt or Mac ports or any of the other system package managers that I use, whereas CDR DAO is. So I tend to prefer things that I can get easily as opposed to checking out random GitHub repos. So I'm going to use CDR DAO. And like I said before, this will create a bin queue pair that can be used fine here. It should be usable in any emulator you come across, but there are other projects related to SOTN that are expecting a very specific bin queue pair, or sorry, set of bins and a queue that this may not work with. So if you're planning on using this for other things, just a word of warning that it may not work with those tools. Just kind of going over what's happening here. We're going to read the raw disk. There's some things on PlayStation disks that ISO file systems don't necessarily like as they're implemented in most operating systems. And we also want the raw audio that comes at the end of the disk as well. So we just want a raw dump of the disk. We're going to save this to soten.us.bin because that's the version that it is. Our device on this Ubuntu image is SRO. It's been a long time since I've used CDs in Linux. I don't know where the SR prefix came from. That's new to me. And then there's CDR DAO implements several different drivers, and typically the generic driver will work fine, and that's what we're going to use here. And then instead of queue files, CDR DAO writes to talk files. And of course I screwed up my args somehow. Oh, it was not drive, it was device. That was where I screwed up. No, I did. Oh, driver. So this will run, and like I said, this will take a few minutes to run, but this will pull down a bin now that is, for all intents and purposes, a perfect copy of the disk. While this is running, I'll catch up on chat. Decompilation, I wouldn't say is a black art. It is an art. One of the comments on YouTube was, how did you get into assembly to begin with? I happen to be, I think, born at the right time in the right place. When I was in my undergrad degree, our operating system course was taught in assembly. So we had to write an operating system in 68 HC11 assembly, which is Motorola microcontroller. Not quite the same as a Motorola 68K that a lot of the 16-bit systems used, but that a lot of the concepts there translated over well. And so a few years ago, I got pretty deep into Motorola 68K and felt like that helped. And then we had another embedded course still in 68 HC11. And then our computer architecture class, we were building a MIPS CPU, and I don't think I have it on my shelf near me, but I should. I think it's in the garage somewhere. I should dig it out. I think I still have a MIPS book from then. So I haven't looked at MIPS in about 20 years, but I had some experience there as well. Along the way, like more like traditional career, the type of definitely doing more high level stuff, C, Java, interpreted languages, but had to build some low level tools in Java, so understanding the bytecode there, following Clang development and its bitcode. Here and there, I just had chances to refresh my memory along the way. So that's kind of how I got into a place where I felt confident doing some of the decompilation work. This is it's possible for anybody. It's definitely a different way of thinking about programming. There's much more, I would say, I guess, freedom to do things because you're just poking at a processor, telling it to update registers or memory addresses, as opposed to something more structured. As unstructured as we think C is, it's much more structured. Is it versions that they expect? If you want to clarify roaming, I'll get back to that question. Yeah, I was thinking about that too. I happen to have a UHD Blu-ray drive because I like ripping all of my things, and so that suits me well. I'm actually just using a USB disk drive that I had off in a box somewhere. Yeah, so the GameCube, Wii, Xbox 360 generation, there's so much PowerPC there that that's probably something like looking at the Xbox 360 version of the game, something that I probably want to get back into as well. Yes, yeah, randomizers. Not necessarily certain versions, certain rips. They're expecting, from what I remember for the like the main randomizer, they're going to be writing to certain offsets, and when CDR DAO comes in, it might pull in extra null bytes at the beginning of the disk, depending on what the drive capabilities are. And there are synchronization bits that happen to identify where the first sector of the disk is, but you have to scan through the CD data to find a set of, I think, 11 or 12 bytes, all with a specific sequence to see where the start of the disk is. And depending on the drive, depending on the disk, those may pull at different offsets. I tried this on like a generic cheapy USB drive, as well as a really nice LG drive, and I got two different MD5s. I was going to post an MD5 of what this would look like, but they both produce different MD5s. When you look at the queue or the talk that gets created, both of those are identical. And so you have these table of contents file or the queue file that are saying the same thing regardless of what your RIP looks like. They're both depending on whoever's reading that disk to find those synchronization bytes and then base every offset on that. Okay, so our RIP is done. I might do an MD5 here just to see if this matches what I had before. And it doesn't actually. So the talk is the same, and the talk should always come out with this, regardless of what drive you use, you should get the same MD5 here. But multiple runs on the same drive are giving me different MD5s for the bin, and that's just the nature of CD ripping. There's so much other higher level processing that goes on that raw data and differences in that raw data don't necessarily make a difference by the time you get to the ISO 9660 level and are extracting files, or even the audio level. You'll get the same bits out eventually, but what we have in this dump isn't necessarily the same as all of them. So we can't rely on that. If you look at redump.org and any of those tools, what they're doing is looking at the offsets from the cue or the talk to the next track. And those will match. But this process of just doing a single bin isn't necessarily going to match. So CDR-DAO gives us a table of contents file, but we need a queue. And the CDR-DAO package comes with talk to queue to do exactly that. And so we're going to convert that talk to a queue. And it'll give us some info. Apparently, that conversion is lossy, so it just wants to warn us about those things. So we're almost ready to go, and I think I can extract the disk now without issues. But I'm going to make some changes. If you're watching this at some point in the future, these changes shouldn't be necessary. So ignore this spot. I was going to have some like flashing banner at this point to ignore this. This is kind of a look behind the curtain of some of the changes that are going to be made, or that I think should be made. So many of the tools here, like I said, are relying on the system Python and modules being stored at the system path. And so we're just going to encourage those to not use that Python, but use the Python that we have locally. And to do that, we're going to use the env utility. If you're not familiar with userbin env, it's a utility that looks at your environment, and specifically the path variable, and is going to find the Python 3 that's close, that's most matching in your path. So whatever the first path that it finds with a Python 3 in it, it will use that one. And so with venv, setting our path to our local Python environment, we'll get our local Python as opposed to the system Python. And if we just had the system Python installed, it would work as well. Scripting languages have used this technique for quite a while to be able to differentiate where their interpreter is stored on different systems with different package managers, things like that. So it's not something that would break even the base build system. And I've tried it there as well, and that works fine. So I think there's 4 of these to get a build that I'm going to have to edit. I consider this just good script hygiene in general. But again, don't worry about this. Hopefully this will be checked in by the time you'd be interested in following this tutorial. And if you're following along, I'm editing the shebang on several of the splat extensions and PNG to bin, and I think those are the only ones that that matter. We'll see soon enough. So I'm going to make extract disk, and so that's going to look at the disk that we extracted. First it's going to build a tool that we have for extracting the disk, and then it's going to extract the files that we need before we can start pulling code and other things like that. Yes, referring to Luigi's Evil, again, I still don't know if you're talking about Mario's brother or not, but if you get a mismatch for the bin, that's not necessarily an issue. And if you like known hashes, CDR DAO is not the tool to use. There's other tools that will give you the correct hashes. And I have some other tooling that I built for Sega CD related stuff that doesn't work perfectly for this, but it will actually go through and like do a file MD5 given a bin, and that should all the files should hash to the same thing. Is there a point in setup at which you could MD5 to check for a good extract? That is that's not a bad idea. I'll add a note for myself to consider that. So going through this process, I think 3 or 4 times this morning, as well again here, there are a bunch of notes that I have to make onboarding a bit easier. The first one is we have make targets to make a lot of these things easier. Having a make that's going to extract or dump the disk, I think, would be helpful. But then, yeah, doing a MD5 against these, I think, is helpful as well. We know what all these are, and so we should be able to have hashes out there. All right, so we've extracted the disk. Let me make this comment to myself. Okay, we've extracted the disk. Now we're going to run extract, and I use J. J tells make use as many processes as possible. So make will create a dependency list for itself of all the things that it needs to do. J will say run as much as you can in parallel. If you want to limit it to the number of processors you have in the box, you can do that as well. But in general, these are I/O bound tasks, and so I haven't found that overloading this with too much ever result in any time difference or savings. And if I did, if I fixed all my scripts to use the environment Python, this should work just fine. And it looks like it did. And if so, this is something that's done a lot. Splat is used to extract code and assets and data from each of the files that we pulled from the disk. And so we might go through all of that configuration is in config. So we might look at NO3, for example. This is the instructions to splat. These are files that are checked into the repo. At how to look at look at this no3.bin file, and then extract the different parts of it and what they should look like. And so that's what the extract target does in make. So now that everything's extracted, we should be able to run make, and it will rebuild the objects that we have configured. So 9 or 10-ish stages, the first weapons, Richter, Dracula, the main driver. I'm going to run that with J as well, so it goes fast. This takes 14-ish seconds or so on my local machine. And we did get an error, and that's likely because I forgot something, but it still succeeded fine. I'll have to go back and see what that error was. It looked like probably another one of these Python path issues. So we ran make, and now we get a list of all of the objects that we've started decompiling, and as long as they all say OK, that means what we have works. And at this point, I go through and I look for where do we have functions that are not decompiled yet. Those are files that are referenced with the include ASM macro. And so for weapon, I might look in the weapon directory. And like I said at the beginning of the stream, we still have 3 functions that are left to decompile, and I'd go on from there. After we've done the extract, all of that assembly is in an ASM directory. So ASM, the version of the game, in this case, we're looking at the US version of the game. Weapons, non-matching functions that haven't matched yet, and so in this case, we might want to look at weapon 30, and we should have an assembly file here with that assembly. So then this file is, the contents of this file is copied and into decomp.me, where it's decompiled mechanically, and then we can go through and do our match. And I think one of these Weapon 30 files is one that we will work on now. So that's the kind of getting started from nothing to getting a working build for the PlayStation version. The way that you extract contents on the Saturn version should be identical, except you need a Saturn disk instead of the PlayStation disk. If you want to extract your PSP disk, that becomes more involved, and you'll need a PSP with custom firmware and either Filer or some other tools. There's tutorials online for how to extract your PSP version of the game as well. The others that I've looked at are the Android and iOS version. Those also are a bit more complicated. You need the versions of the games. You need a way to, for the Android version, usually you can download the APK pretty easily from your device. The iOS version, getting that isn't as simple. The iOS version of the game can't be installed directly on Mac OS, so you don't have file system access necessarily, but there's other ways to, there's tools for extracting that as well. And then the Xbox 360 version is the last version that I've looked at. When you look at the file system contents on Xbox 360, you don't get a lot of the files that the 360 ends up using, so there's a bunch of custom tools there to rip Xbox 360 disks, and you have to decrypt those files and access them that way. I'm not going to go through any of those here, but there are ways to do that with your own disks for those other versions as well. If we want the PSP version and want to compare code for the PSP version, we need those files dumped to be able to extract, and same with all the other versions as well. So I think that's about it for setting up an environment. If there's any questions related to that, I'll come back to it. Otherwise, we'll go and we'll start looking at these remaining Weapon 30 functions. I don't recall if any of these had been, or how far along any of these are, so I'm just gonna look and see what the state of these is. Oh, probably would be helpful if I specified. So we do have matches that are still quite a ways away. These may be too gross to look at on stream, and maybe I'll look at some of the Marble Gallery stuff that's new. I haven't looked at that yet. There may be something relatively straightforward there. So we have, Josh has a 97% match on this second one. I just want to see what may be missing. So some masking down below. I'll take the naive approach and see if we can just mask. And I also want to see here if this... so this is being saved as a 32-bit value. The mask may be the conversion to 16-bit. The mask somewhat implies, though, that it's unsigned. I'll leave that there. I think some of these where there's just little tweaks here and there, if they haven't been solved by other people, they're mostly things that probably require a lot of deep thought. And that's less interesting to do on a stream. So I'm going to skip those, and we'll look at some of the Marble Gallery stuff. So I haven't looked at this yet. This is brand new from this weekend. So I'm going to... oh, is it? It is Boss. Maybe it's not Marble Gallery. So yeah, Biz Murphy's comment. This is relatively early for this new overlay, and it's certainly possible that not all of the functions have been found yet. In which case, there may be more to do than what is currently here. So I'm going to do what I've done in the past and just look for those assembly files and find the smallest one. I should have limited that to non-matching instead of data. We don't want to work on the data right now. So we have some small ones, and I always say small does not mean easy, and large does not mean difficult. Let's choose something right in the middle. Yeah, so when Splat does a pretty decent job of identifying what the function boundaries are based on different conventions for what the prologue and epilogue of a function looks like. But sometimes as you're, what I've seen for some of the other ones that I've looked at, as you're going through, you can kind of refine and more things shake out along the way. So we're going to do PlayStation, and let's look at this and see if we need a jump table. This looks fairly straightforward. There's likely some symbols that I don't have, and may run into some context issues there. But we'll give it a shot. This is the first time in a long time on the stream that I've looked at fresh code that I haven't seen before, as opposed to something in one of the weapons. So yeah, we do have several symbols, it looks like, that aren't defined, some structures that we have to go find. So there's some work to do to update the context first before we can get in. So current entity, I'm not sure why the decompiler didn't like what was in the context there. I'm going to look for this symbol and see if there is a declaration for that somewhere. It doesn't look like it, so we'll have to go through and look at how it's being used here, as well as what the data looks like as well. These other two symbols, the decompiler thought were 16-bit values. And let's see if there's anything that suggests otherwise. So this is just an increment. There's not much we can, as long as those are 16-bit loads and stores, that should be, the decompiler should be able to figure that out. And then this var e3 is similar. There's nothing there really that suggests that it's anything other than a 16-bit value, so I'll trust the decompiler there. So let's look at this first one and see if we can find how this is mapped. It's not used outside of this function. And it's also possible that this boundary hasn't been... Oh, what am I doing here? Okay, so the boundary is defined, which is nice. Unfortunately, it's in SBSS. BSS data is zeros, so we're not going to be able to glean much from this necessarily. We can find the size. It's unclear from looking at the data whether it's related to the following values or not. So this may be a pointer, or it may be this value. Let's see how it's being used in the code. So it is being used as an array, and our index is here. So we have at least 5 of these, and looking at the data, it looks like there's 8 or so, 8 words consecutively. 9? 9. So I think it's a pretty safe bet that this is an array of 32-bit values, but we'll see. We'll see how it goes. So I'm going to just make that assumption, and then let's put that into the context and try again. Roman, yeah, feel free to look at weapon 17. There's just a bit more. So I think in my scratch for that, I have been trying to put links to the PSP version and the PlayStation version so that you can cross-reference them easily. So yeah, feel free to look there. I think the PSP version was more matching than the PlayStation version, which is kind of a unique thing. Usually when you get the PSP version, the closer you get, the PlayStation version is matching more, but something is a little off still there. So let's run a decompile again and see if that helped at all. It doesn't, which is a bummer. But that's okay. We can get past that. Oh, I see. Somewhere in my context, I have a ifdef related to PSP, which is probably causing problems. This is, it's unfortunate that M2C doesn't recognize that, but it doesn't. So let's try to decompile again, now that we've cleaned that up. That's probably something I should file a bug with M2C about. Let me post the scratch as well. I'll post that in chat. And if you want to fork it, do whatever you want. You can follow along as well. So yeah, fixing my context, my broken context, gave me a clean decompile. We still have some offsets that are not clean. So what we have here is not actually a array of 32-bit values. Well, it is 32-bit values, but those values are pointers, and they're pointers to a structure that we need to figure out what it might be. Hypothetically, if it was a duplicate. Either way, yeah, I did jump right into this without looking whether this was a duplicate or not. Let's look at the duplicates report and see if it's there. I don't have the current version up. I do. Are these not showing up in the duplicates report yet? I'm going to move these back into, just to keep track of what these are. All right, so I will just kind of go ahead. It looks like this. Biz Murphy's suggesting this is a duplicate, but we'll go through this one. We don't always have to get work done. We can sometimes just go through the process and learn a little bit. I used to follow a pretty regimented script when I was decompiling about how I set up my scratch and all this other stuff. I should kind of go back to those rules. Because I've been focusing so much on weapons and just getting stuff done, not necessarily going through some of the fundamentals. So I always add no built-in to differentiate between the built-in function signatures of common libc functions that GCC has versus the PlayStation SDK. Not everybody does that. Some people just remove those functions from their context. I don't know for sure that I've run into an issue where the difference in signature between memcopy or string compare or anything like that has caused a compilation issue or a matching issue. So we'll just keep going and kind of follow the normal decompilation script. So what I usually like to do is try to get rid of any errors or warnings first. The main issue that we're going to have here is that because I labeled this array as a 32-bit integer, an array of 32-bit integers, it's actually an array of pointers. We need to figure out what it's an array of pointers to. Usually I'll look at the biggest offset. So these are offsets into some structure. And try to see if, find a structure with that offset, and then from there I can kind of winnow what structures we have defined. So this one has an offset of D, for example, 19. So I want to find something where offset 19 is an unsigned 8-bit value, and D is also an unsigned 8-bit value. It looks like unknown A may or may not be a 16-bit value. So we have 3 or 4 different fields that we can look at to try to find a structure that may already exist. So I'm going to look for offset 19 first, and we have all these in a header. It's possible that these are maybe primitives. We'll look at primitive and see if that fits. We also want to look at the assembly. We can see what this is being multiplied by. So we have an offset into an array. Depending on the size of the structure of that array, we'll have to multiply that to get to the correct offset. So we want to look for, it's easier if we have something that's compiling to find approximately that line. So we have our array here. And where are we multiplying? A1. Here's our shift. We're just shifting that by 4. Oh, silly me. These are pointers. Of course they're going to be 4 bytes. That doesn't help us. We don't have an array of structures. We have an array of pointers. Pointers are going to be 4 bytes. So let's see if this primitive, we have offset 19, which is V1, offset D is V0. So those actually line up pretty nicely. Unknown 32, I missed unknown 32. That's our draw mode, and draw mode 8 is it draw hide? Let's look at draw mode. It is draw hide. So this looks like a primitive. So we don't have an array of 32-bit integers. We have an array of primitive pointers. And so we'll do a decompile again, and that should give us the right types. And maybe we'll get something that compiles now. And we do. And we're at about 84%. All right, so once we get something that compiles, now I want to go through and try to reduce the number of variables as much as possible. Usually, like in this case, there's a do while loop. That's not idiomatic for most of the code here. For loops are typically used, so I'm going to go through and just kind of clean a bunch of that up as well. So here we have this var A3. This looks like we're iterating over that. And can we unroll this for loop in a way that makes sense? We'll call var A3 our prim index. So this this first block looks like we want to constrain this to one of 5 values, and we're just going to be iterating through each of those in step. What I want to see is whether or not we need the second primitive index. It doesn't look like we do. Nor do I think... so this may be better written as while prim index is greater than or equal to 5. Sorry. Nah, there's not a real while keyword there. We're going to subtract 5. I don't know if there is any... if any of this other logic even matters. Where were we before? We were at 0. I should have saved to get an idea. Yeah, so this ends up working out. So sometimes the logic looks complex, and the decompiler doesn't recognize this particular pattern, but it ends up just being a for loop without a body. So now we have this var v1. What are we using this for? So this is going to be I in the loop below. It's being set multiple places, likely because as this was being optimized, different branches result in this value being set, and so it may appear to be set multiple places different times, but I don't think it is. I think it's just I in this loop. And we'll see if that's the case. So we're doing a loop against up to 5 times. And then our inner condition is as long as that I is not equal to the index that we loaded earlier. And we're going to be pulling from this var e2, which is some offset into this array of primitive pointers. The only time that we are using that is here, and so likely this is just indexed, and we can get rid of a bunch of this stuff. So that got us up to 90%. That's looking better. So this temp A1. So this is our primitive. So we'll rename that. Where did the _2 come from? That looks like maybe something that I missed along the way, but this looks like it's just going to be prim along with A1. And we'll have to get rid of this extra declaration, and I think var A2 is already gone. And we don't have a second primitive index, and we don't have a var1 either. All right, so we're at about 90%. We're not out of the woods quite yet. There is this increment at the bottom. Sometimes changing using an increment operator instead of doing a plus equals makes a difference. In this case, it doesn't. So there is something else that may be going on. Is it possible that this is inside this loop? I want to see where these branches end up going. It looks like we're branching equivalently. This may be a array as opposed to just a single value, and offset 0 is being referenced. So let's look at our definition here, or declaration, sorry. And let's try that. It also may be a struct. That worked out. So we'll keep it like that for now. That it's possible that that is a struct as well, and we're looking at the first field. Yeah, I agree. So Biz Murphy mentioned if they want to keep prim index below 5, why not just mod 5? I can't imagine that it's going to generate the same code. We could look at the difference between the two. So we'll set this outside. Actually, we could just all do this all together. So looking at what this generates, not knowing what the cost of any of the specific instructions are, I don't know why you went mod 5, but it didn't. Okay, so cleaning most of it up got us pretty close. Let's look to see where the remaining issues are. So there's register differences. Prim index probably is not 32-bit, it's probably 16. Oh, it is 32. Surprising. So what could be causing our register differences? So one thing I want to look at is whether A0 is being used. We don't have any other function calls though, so that shouldn't make a difference in this function. That might signal whether or not we are the function signature is returning a value or not. It's not being used regardless. Yeah, there's in this case S32 is type def to int, so there's no difference between the two. And I don't think GCC is affected by local variable ordering. Let's try this. These instructions are all correct. Occasionally those will work out. This is a possibility as well. Oh, where is this ad coming? Line 12. So what if we reorder these into the logical order? Doesn't fix our registers. There is a possibility that this is being pulled out. I removed any of the variables there. Not a particularly like I don't think that there's anything specifically interesting about pulling that out into a separate variable. So I'm not try it, not try it. I don't think that makes sense. The one possibility is down here, but the correct instructions are being generated. So what's interesting about what GCC generates versus what we write in this case is this for loop appears to be taking this array of pointers, indexing into that array of pointers, and then referencing some field in the pointer that's stored here. The way that GCC wrote this, however, was it took out a variable, and we'll call this just P. It's writing it as if P is being set to this field, and then P is being accessed directly, and then P is being incremented separately, or possibly like this. And there's some details here that you would need to get right to make this match perfectly, and I actually don't know if you could make it match perfectly writing C the way that GCC compiled this, but GCC knows that effectively every time we go through, we're going to be accessing the next value in this array of pointers, and it's cheaper to add 4 to a pointer than it is to recalculate this address each time. Let's see if there's any. So offline, in if you're in the decomp, you'll know that Sozu gave me a hint. Oh, I do want to stay on this page. Let's look at the correct answer. That's not it. So let's see where we differed. So nope, this is not the right one either. Nope, not that one either. Okay, so let's thank you, Biz Murphy. So this was first seen in the Maria cutscene in NZ0. Let's see what I'm getting wrong. Ah, okay. So this is a couple things worth looking at. This was actually relevant to a comment that somebody made on YouTube. Why can't the decompiler just generate correct C code? So when we go through this and kind of reason about what the decompiler is doing, this instruction for instruction, we have an identical set of functions. The difference between what this C code does and what the original is doing is just how registers are being allocated. So looking at so this is a duplicated function. It exists already. This particular offset is known, but for the sake of our decomp, it's not. And actually, this hasn't been given a symbol name yet in MAR. So I said at the beginning, this looks like a for loop to me. And if you remember from the decomp originally, this was a relatively convoluted condition and loop inside. This wasn't written as a for loop, though. It looks like, at least for the previous version of this decomp, it is a while loop with some logic inside, which is logically equivalent. Let's see if this gives us the correct registers then. It doesn't. Oh, am I missing a minus equals at the bottom? Ah, because we're already looking here. Got it. So we were subtracting the wrong thing. It still is not an exact match, however, and I wonder if this mask is necessary. It is. Let's see what else. So there was a separate load and store in the original. I'm looking through, and we can pull this up. So this is the matching function. So when we have a matching function, we might have addresses that differ between the two, but the instructions are generally the same. So this is taking a unsigned 8-bit argument. We'll see if that helps us. Relatively close. We have all of the same variables otherwise of the same type. Yeah, the only other difference I see is that this is being pulled out. This pointer is being pulled out separately, and then and that looks like it worked. So this is one of those things where again, it's logically equivalent, but just based on the different structure of these statements, the compiler is going to do different things, and the different things that it was doing was just related to the registers that it was allocating. And so would that perform the same operation? I'd have to go back and look and make sure the registers were all the same, but it looked like the instructions were. So there's a pretty good chance that it was going to do the same thing. We could try to rewrite this to match what the other version of this function does as well, with the while loop. I was a little curious to see why it generated different code before. Okay, this matches as well. And so this is the implementation that exists in the Maria cutscene overlay for NZ0 as well. So sometimes there are little things like that. We can kind of, let me save, I'll save it here. There are little things that do differ. It does look like this would have been incorrect the way that I had it written. So we, because this primitive is going to be pointing to the wrong thing, but when it was in this form, this would have been logically equivalent. But for whatever reason, it doesn't compile to the same thing. There's extra and that's not being generated. There's different things that GCC likes to do in these cases, and I think it's because the loads are happening in line. It makes assumptions about what could possibly change in the meantime. And then we'll use that information to optimize in slightly different ways. So had I not been able to to reference this this other implementation off screen, I might have thrown this into the decomp permuter and had it run and give me some hints there. A lot of times these smaller functions where everything seems extremely obvious can be more complicated than they look, and that's why I say a small function doesn't mean easy and a big function doesn't mean hard. There are just little idiosyncrasies when you introduce a optimizer and different tricks that a lot of people spent a lot of time thinking about to get as much performance out of a particular CPU as possible that you're not necessarily going to be able to reason about. Does the compiler optimize to write negative offsets of pointers? Yes, it does. So some of the, I believe it's the remaining function in DRA does that, and so if you, when you run the decompiler, you'll get a bunch of negative indexes, and typically that means you are iterating through some array of things, and the compiler has chosen, for whatever reason, to use an index kind of in the middle of things, and it will or use a pointer value in a register that's kind of in the middle of things. I haven't looked deeply into MIPS enough to know if there's advantages to using smaller offsets or not. Maybe it's related to, I don't know what the MIPS cache looks like. It could be related to a bunch of things around that. Yep. Thank you, Biz Murphy. Very, very similar comment. So I think that's all that we have today. We can actually we can pull this into the project and just watch it give us okays, which is always very satisfying to do. Even though this one was done before and would have been caught by the duplicate finder, it's nice to be able to do it on our own every once in a while and see what happens. We'll need our declarations. We may need to pull in the primitive header. I'm going to make the assumption that it's coming in already through stage, but if not, we can fix that. So let me grab those declarations and paste them in. now when I make, I didn't get rid of ASM. All right, so we got it compiled and it is matching. So as has been mentioned several times, this one was a duplicate, and there is some this mar.bin. There's a lot of active work going on here, so I'm not going to submit this one because this will be probably picked up as part of other sweeps of duplicate functions. But there's probably other things in here that are worth looking at, and maybe I'll spend some time either with the duplicate finder to find things that aren't duplicated here, and tomorrow we can look at some of the other functions. I'll spend a little time there. That is all that I have for today. If you want to know more about the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev, where you'll find a link to the GitHub repo as well as the Discord server, where there are a lot of friendly people. This is honestly one of the friendliest groups for an open source project that I've come across, and it's just very welcoming and inviting, and very excited to have found this great group of people. I am not in any way an important person on this project. I'm just a contributor. I like doing these streams because it's fun for me to decompile. I like talking about it. I like talking with other people about Symphony of the Night decompiling, and just software, building software in general. There are many people that are contributing to this and doing incredible work. And definitely, if you want to say thank you, go say thank you to Biz Murphy, Sozu, Zynamo. They've really set up a great community and great environment. There's dozens more that have contributed, doing great work as well. Sorry if I didn't shout out your name, but you all know who you are, and just look at the history in the GitHub repo and see all the contributors that that are making this an awesome project. Definitely, if you're interested, stop by the Discord chat. If you just want to chat about Soten or whatever, there's channels for that as well. And I'll be back tomorrow with maybe some new stuff, maybe something else. If there's comments, questions, or whatever, then feel free to chat. Follow on Twitch, subscribe on YouTube. This will be up on YouTube in a couple days. Hi, YouTubers. Thanks for all your comments and all your support. I enjoy interacting with you too, even if it's not live. And yeah, we'll be back tomorrow. Thanks, everybody.